Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 29 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 3021. Alice and Bob playing flower game. So let's read the problem statement. Alice and Bob are playing a turn-based game on a field with two lanes of flowers between them. There are X flowers in the first lane between Alice and Bob. So let's say this is first lane, and in this first lane we have X number of flowers and Y number of flowers in the second lane between them. So let's say this is a second lane. Done. Now the game proceeds as follows. Alice takes the first turn. Alright. And in each turn, a player must choose either one of the lane and pick one flower from that side. Alright. And at the end of the turn, if there are no flowers left at all, the current player captures their opponent and wins the game. Alright. So see here. Alice is going to take first turn, right? So this is one lane and this is one lane, right? And here let's say Alice is here and here we have Bob, right? So Alice is going to take the first turn, right? So let's say Alice moves to this side. Then she is going to pick one flower from here, right? She is going to pick, a player must choose either one of the lane and pick one flower from that side. Okay, let's say she pick this flower, right? Now next time Bob, right? So Bob is going to take his turn. Then again, it's Bob's choice, right? Bob can go to this lane or this lane, right? Again, let's say Bob also moves to this lane. Then Bob is going to pick one flower from here. Done, right? After that, Alice's turn is there, right? And only one more flower is left. Only one more flower is left. Let's say that flower here, or maybe you can say that flower is here. Okay, your choice. So now Alice is going to pick that flower, right? Alice picks the flower. Now there is no flower left, right? There is no flower left for Bob, right? And Alice captures the last flower available, right? So Alice is going to win this game. Clear? So Alice takes the first turn. In each turn, a player must choose either one of the lane, right? And pick one flower from that side. Alright. At the end of the turn, if there are no flowers left at all, right? The current player captures their opponent and wins the game. So in the end, Alice captures the last flower and there is no flower left for Bob. So Alice wins the game. That's it. Right? So Alice in total, in this particular example, she captures two and Bob is only able to capture one flower. Right? Done. Now here, after that, given two integers n and m, the task is to compute the number of possible pairs x and y that satisfy the conditions, right? So we are given two integers n and m, right? The task is to compute the number of possible pairs x and y. X means number of flowers in this lane, y means number of flowers in this lane. So compute the number of possible pairs x and y that satisfy the conditions. Alice must win the game according to the described rules. Alright, so we want Alice to win the game. The number of flowers x in the first lane must be in the range 1 to n. 1 to n. Alright. The number of flowers y in the second lane must be in the range 1 to m. Alright. We have to return the number of possible pairs x and y that satisfy the conditions mentioned in the statement. Alright. So very easy problem, right? Here see example number 1. And these are the constant size. N is 3. N is 3. N is 3. Alright. And m is equal to 2. Right. So here the number of flowers x in the first lane must be in the range 1 to n. Alright. So it may be just one flower. Alright, here. Or it may be two flowers in the first lane. Or it may be three flowers in the first lane. Right. These are the possibilities, right? It may be 1, it may be 2, it may be 3, right? So here it is saying the number of flowers x in the first lane must be in the range 1 to n. The number of flowers y in the second lane must be in the range 1 to m. Alright. So it may be just 1 in this lane or it may be 2 in this lane, right? Okay. What I want Alice to win, right? I want Alice to win. Okay. So first Alice is going to take turn, right? Alice is going to take first turn, right? So let's say I'm going to denote Alice with this color pencil, right? And I'm going to denote, let's say, Bob with this color pencil, white color, right? And this you can say red color. Okay. So here let's take scenarios, right? So here maybe we have 1 or 2 or 3, right? So let's pick this scenario first. we have one flower here and we have one flower here. Okay, in this we have one flower and in this also we have one flower. So I pick this criteria first. Okay, this one. So first Alice is going to pick this. Done. Then Bob is going to pick this. Oh, Bob wins, right? There is only one flower here, one flower here. Last time it was Bob's turn, right? And there is nothing left for Alice now, so Bob wins. So here that simply means this 1-1 is not the best case, right? One flower in X in this first lane and one flower in, let's say, this lane, right? This is not the best case, right? Clear? Okay. Now here after this, okay, after this, let's say I pick this uh, one flower here and here let's say I pick two flowers, right? So let's see this. This is one lane, this is one lane, and in the first lane we have one flower and in the second lane we have two flowers, right? I pick this. Now here first Alice is going to pick, so let's say Alice choose this. Now it's Bob turn, right? So let's say Bob is going to choose this one. Let's say now next time let's say Alice choose this. There is nothing left for Bob, right? And it was Alice turn last time, right? So Alice is going to win, right? So here in this case, one flower in X lane and two flower in second lane, right? So Alice is winning in this case, right? So here here Bob wins, right? I don't want this case. This is good, right? Because Alice wins, right? So this, let me mark it. Okay, so here Alice wins, right? So this is one scenario I have checked, two scenarios I have checked in total, right? So now let's check some other scenarios. Let's say here 2 and here 1, right? This may be the scenario, right? So here let's say 2 and 1 here. Okay, so now again Alice is going to take his turn first. So let's say Alice pick this, right? And then Bob is going to pick this. Then it is Alice's turn, right? Alice is going to pick this. Again, Alice wins, right? There is nothing left for Bob. So this is nothing but this case 2-1, right? So let me mark it. So in this case also Alice wins, right? Again, Alice wins in this case. All right. So now next time, let's say I choose this and this. Okay, two here and two here. So let's check this scenario also. So two flowers in X lane, two flowers in Y lane. Again, Alice turns comes first. So Alice, let's say Alice choose this. Okay, then Bob is going to choose this. Okay, then Alice turn. So let's say Alice choose this, and then Bob's turn. So let's say Bob chooses this. Oh no, Bob wins, right? There's nothing left for Alice, and last time Bob picked the flower, right? So in this case, Bob wins 2, 2. Bob wins, right? So this is not the best case, right? Okay, this is done. Now after this, let's move to our next case. Okay, so here what you need to do now. All right, so here let me just remove this. Now let's check this. First this and first this. Okay, so 3 and 1 1 here, right? So let's draw this. 3 flowers in this and 1 flower here. Okay, so now again Alice turn. Let's say Alice pick this, then Bob's turn. So let's say Bob is going to pick this, then Alice turn. Let's say Alice pick this, then Bob's turn. Let's say Bob is going to pick this only. There's nothing left for Alice, right? So Bob wins, right? So this is also not valid. 3, 1. This is also not valid, right? Now last turn, right? So now here let's say this and this, 3 and 2 here. Okay, so 3 here, 1, 2, 3 and 2 here. Okay, so here again Alice first, then let's say Bob is going to pick this, then Alice, let's say Alice picks this, then Bob's turn, Bob is going to pick this, let's say, and Alice turn, Alice is going to pick this, and that's it. Alice wins, right? Here 3, 2. So Alice wins this one, right? So let me mark it star. Okay, so in this case Alice wins. So here now if you notice one thing, notice here one thing, Alice is always taking odd number of turns, right? First turn, then third turn, then fifth turn, then seventh turn, right? And here Bob is taking always odd number of turns, right? First two, or even number of turns, right? 2, then fourth turn, then sixth turn, then eighth turn, like this, right? So Alice is taking odd number of turns and Bob is taking even number of turns, right? Okay, so now here if you notice, Alice is always winning when there are total odd number of turns are there. So 1 plus 2 is 3. 3 is nothing but odd number. 2 plus 1 is nothing but 3. 3 is the odd number. 3 plus 2 is nothing but 5. 5 is odd number. Same way here, Bob is always going to win when there are total number of even number of turns. So 3 plus 1, 4. Okay, 4 plus means 4 turns. Bob wins. 2, 2, 4. Bob wins. 1, 1, 2. Even. Again Bob wins. So from here we conclude that Alice is always going to win when we have total number of flowers as 1, 3, 5, 7, odd, right? I'm saying odd, right? So this is what we want, odd. So here if you see in this case, the following pair satisfies conditions described in the statement. 1, 2, odd, 3, 2, odd, 2, 1, odd, right? Okay, so from here we conclude that Alice is always going to win if in total we have odd number of flowers, or I am saying that x plus y value that I am going to pick, it should be odd. Okay, this is what I'm saying here. Clear? All right. So here next time if you see this case, okay, n is equal to 1 and m is equal to 1, right? So here okay, so here you can see you have this choice, right? N value is from 1, okay, and m value is also 1 to 1, right? Only 1, right? So here this is the only case you are going to pick, right? One flower here, one flower here. So first Alice is going to pick this, then Bob is going to pick this, then there is nothing left for Alice, so Bob is always winning, right? So no pair satisfies the condition described in the statement, right? Okay, so 1, right? So here also we are choosing pairs like this now, 1 and 1 first, right? We have to pick something, right? Here see 1 to m, here also 1 to n, so definitely we are going to choose 1 and 1 from here also, right? Okay, so it's not like I'm just going to pick one flower and here I'm not going to pick anything, right? So I will just check now if there are total sum coming out as odd, right? So definitely one we will never get, right? Because here if you see the constants also, and m is also starting from 1, right? So 1 it will be there. So if I do x plus y, so definitely I will start from 2 only, right? 3, 5, 4, I will get all these values, right? But it will never be 1. So I will just make sure that sum is odd, right? This is what I need to find out, right? So now here when my n is odd, when my n is odd and my m is even, okay, when my n is odd and m is even, so in total I was able to find total 6 pairs, right? 1 2 3 4 5 6. So I can say n is 3, n was 3, right? Previous example, m was 2, so n into m is going to give me nothing but the number of pairs. 3 into 2 is equal to 6. So 6 is nothing but the total number of pairs, total number of pairs. Okay, this is done. Now among these total number of pairs, 6, how many are odd and how many are even, right? This is the next thing that we need to find out. So number of odd pairs is nothing but n into m divided by 2, right? So 6 divided by 2 is nothing but 3, and 3 is the total number of odd pairs, right? And 3 is my output also, right? Here if you see 3 is my output also, right? Okay, so here this is one thing, right? And you know one thing, when I'm going to get my x plus y as odd, okay, so I'm going to get that when my x is odd and my y is even, then I am always going to get my odd number, right? Same way when my x is even and my y is odd, then also I'm going to get odd only, right? Even plus odd is also odd. When both are even, then I will always get even number, right? Or when both are odd also, then also I'm going to get odd number, right? Okay, so here when my x is odd and y is even, so see here odd even, odd even, even odd. Okay, so odd plus even plus odd, right? Then we are going to get odd only, right? So this is one more thing. All right, so here I have explained when my n is odd and m is even, then okay, so now let's suppose when my n is, so here you can think about think it like this, n odd m even, right? N odd or m even, this case. Or you can also think it like this, first n is even or next one is odd. So I'm saying case 1, when 1 out of n and m is odd, only 1 out of n and m, 1 is odd, then in that case the total number of odes is going to come out as this, n into m divided by 2, that is 3. Okay, now here when both are odd, let's say n is 3 and m is equal to 3, when both are odd, when case 2, let's say this is nothing but my case 2, when both are odd, so then total number of pairs, how many total number of pairs I'm going to get, n into m, 9, right? Total 9 I'm going to get, right? So here okay, so here n into m is equal to 9, right? So now here how you are going to get, what are those pairs? Maybe one here, right? Or you can get 1 2. Okay, let's say na, let's understand it like this. N is equal to 3 means, let's say a b c, and m is equal to 3 means here d e f, let's say. Okay, 3 we have. So here how many pairs in total you can form? You can form pairs like this na, a d, a e, a f, b d, b e, and b f. Okay, now it is easy for you, right? C D, that is why we are doing 3 into 3, right? N into m, 9. So these are the pairs C D, C E, and C F. Okay, so now here I'm saying when both are odd, so let's say A is 1, B is 2, and C is 3. Okay, 1 2 3, right? Here also 1 2 and 3. So here your odd ones are A and E, A E, this is odd, right? Okay, then B and D is odd, then B and F is also odd, right? Okay, then C and E is odd, CE, right? 3 plus 2 5, right? So total 9 are there, total 9 pairs are there, and odd are 4, right? So how you're going to calculate this? So you can calculate it like this na, n into m divided by 2, again if you do, right? So what you are going to get, you are going to get 9 divided by 2, and 9 divided by 2 is nothing but 4.5 if we do real division. But if we do division in programming languages, we will always get the output of this one as 4 only, and 4 is right. Okay, here also you can simply apply the formula m into n divided by 2, that's it. Okay, again you are going to get 4 only, right? And 4 is the output for this, right? N is equal to 3, m is equal to 3, again 4 is the output. All right, what are those pair odd ones? This 1 2 2 1, right? BF means 2 and 3, 2 3, and here CE means 3 and 2, right? So here if you see odd even, even odd, or even odd, odd even, right? Okay, so here also you can simply apply n into m divided by 2. So we have covered two cases when one is odd, okay, when both are odd. Now case 3 when both are even, case 3 when both are even. Okay, n is equal to 2, let's say, and m is equal to 2. So in that case here also let's say a b c d. Okay, here all right, so how many pairs in total? N into m, 4. And what are those 4? AC, AD, BC, and BD. Okay, so here you can say this is 1, this is 2, this is 1, this is 2. All right, so here how many odd are there? Odd, you can say AD is odd, right? AD is odd, and BC is also odd, right? So here also you can, if you do n into m divided by 2, so again you are going to get 2 only, right? Okay, and 2 is answer. So from here I conclude that if I just write this formula n into m divided by 2, I will always get the output, right? I have covered all the cases, right? And we are always going to win when number is odd, right? X plus y, and we are always going to get odd when one is odd and one is even, one is even, one is odd, right? X and y, for x and y. All right, so here I will just write this formula, that's it. So this is your code, return n into m, n into m. Okay, this is what I have, and n into m, since we have to return in long now, so this number can be very large. Okay, let's say long. All right, long n into m, right? And here just divide it with 2. All right, so now let's run it. Let's see if we are getting a correct output or not. So all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? And the time complexity for this one is going to be of 1, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.